This is naming binary compounds, part 2. We're going to start back with our periodic table, which we should have the ionic charges put up there. Anytime you're able to get a periodic table that you can write on for each test or quiz, I would automatically just write on there those charges. The +1, the +2, +3, plus or minus 4, and then the pattern reverses. -3, -2, -1, and 0. Those charges are there because of what we showed on the last video, because of the addition or losing of those electrons. So the main thing that we need to do is make sure that we can differentiate between our metals and our non-metals. So make sure that you have your stair step and that you've colored in everything to the right of the stair step is going to be a metal, with, of course, the exception of hydrogen. Hydrogen is a non-metal, but these are all going to be metals on this side of the periodic table. These here that I have in a lilac color are inner transition metals, and we're going to have a different lesson if we're going to get to those because we don't always know what those charges are. But we can tell whether they are a metal or a non-metal, and that's what we need to be able to find out. Don't forget, hydrogen is also a non-metal. Okay, these we always know the charge of. These in the lilac we don't always know the charge of. Okay, so going to your notes, the big thing you need to start off with is this right here. First things first. First, check the first element. So, you really only need to remember one difference between ionic and covalent compounds. And that's that if it's an ionic compound, that first element will be a metal. If there's going to be a metal, it's going to be the first thing. So metal first. If it's a covalent compound, then there's a non-metal first. So that's really all you have to look at. What does it start with? Does it start with a metal or does it start with a non-metal? And as we get to polyatomic ions later, what we'll see is that we do have ionic compounds that are composed of cations that aren't just one element. But what you do need to remember is that that cation comes from a metal or a polyatomic ion, but metals are the ones that lose electrons. And the anion will be the non-metal, because they're the ones that gain electrons, or it could be a polyatomic ion with a negative charge. But we're going to keep it simple here, and we're going to do cations and anions that are just metals and non-metals. Remember that cations are positive, right? So a cation looks like it has a plus sign in the middle in the word. Those are positively charged. And the anion, use your alliteration there. The N is repeated because it's negative, right? So naming ionic binary compounds is really simple. You just name the ions present. So here are some examples. So go ahead and take a moment and write these down. And let's look at these. Each compound is going to have basically a first name and a last name. So the first things first, first element, sodium. If I look for sodium on the periodic table, I should be able to see that up there it is, and it's in the metals part. Therefore, this is beginning with the metal, so it's ionic. And that's sodium, and I'm just going to name it sodium. I don't need to change that name at all. The Cl, well, that's chlorine, but don't forget, when we have our binary compounds, don't forget to change the anion ending to "ide." Don't forget to change the anion ending to "ide." Make sure that you write that down. So sodium chlorine would not be correct. This is sodium chloride. The next one is CaCl2. Ca is in group 2A. That's calcium. It is a metal. There's chloride, and you notice that it doesn't matter that we had two here and we only had one here. We're just naming the ion. calcium chloride, making sure that that ending's changed to "ide." K is potassium, group 1A. It is definitely a metal. That's iodine, but our name is going to be potassium iodide. We change the ending to "ide." Last one, sodium oxide. Not sodium oxygen, but sodium oxide. And again, it doesn't matter that there are two sodiums there. We're just naming the ions present and making sure that the anion has the ending with "ide." These are all examples with representative elements or group 1A elements. When we have examples with transition metals, which will be in the next lesson, we'll see that we are going to add to it, but we're going to keep it simple for now, and we'll build on that later. So moving on. Naming covalent binary compounds just takes one more step. We're going to name the elements and then use prefixes to count how many there are. All right, so here's some examples I'm going to put up here. So our first example, I'm looking at the first element. First things first, look at the first element. What is it? Is it a metal or a nonmetal? Well, we have to see where it is on the periodic table. Where is it? Sulfur is right here. It's in the nonmetals. So it's a nonmetal. That means it's going to be covalent. All right, so that tells me I'm not just going to put a first name, last name, just with "ide" at the end. I have to do something a little more. So I'm still going to write, how many are there for sulfur? There's just one, but it's just going to be sulfur. And I do have oxide, but I do have to say how many are there. And I'm going to use a prefix of trioxide, because there are 3. Now the next one, I have 1 carbon and I have 1 oxygen. So I'm starting with 1 carbon, but I'm just going to say carbon, because that's understood that there's just going to be 1 if I'm starting with just carbon. However, on the second one, I do have to say if there's only 1 there. So I'm going to say monoxide. So that's carbon monoxide. On the last one, I have more than 1 of these nitrogens. So I am going to have to use a prefix there to show that there are 2. So that's going to be dinitrogen. And then that prefix for 3 is trioxide. Okay? So that's it. That's the build upon for the covalent compounds. So you've noticed that we have prefixes here, and some of them are pretty easy. Mono means 1, tri means 2, tri means 3, di means 2. So you are going to have to know what those prefixes mean and all of the prefixes that we might use. So flipping over to the back side of your notes page, let's write down what these prefixes are and the values that they go with. And so here they are, and some of these are going to be familiar to you. Mono, di, tri. Tetra might be the only one that's a little bit off. Tetra's 4. Penta, like a pentagon, is 5. Octopuses have 8 arms. Octa's 8. Nona's 9. Deca's 10, like a decade. So memorize these so that when you determine that it is covalent, you can use those prefixes in naming. Okay? So let's practice together. Let me give you some to do, and then I want you to pause the video and see if you can answer them, and then I'll give you the answers. All right, there are the ones to try. Pause the video right now. Write these down. And here are the answers to check. So in these examples, we only had 1 covalent compound. So we only had 1 that we needed the prefixes with, dinitrogen tetroxide. Everything else we could just say the ion name, potassium fluoride, sodium sulfide, and aluminum oxide. Okay, so now I'm going to give you some that you are going to work on your own, and I'm not going to give you the answers to them here in the video. We're going to be checking for them in class. So work these on your own and have them ready for me to check in class tomorrow. All right, there are your independent practice problems for your homework. So let's get those done. Don't forget to do your summary on your lined paper in your journal, those 3 to 5 complete sentences, and we'll check those tomorrow.